Good evening, everyone. Good evening, and welcome to this session of Shastra for mathematics for quantitative aptitude. So, I suppose that you people must have started solving the different question papers, revising the material which you have already done, right? So, what is my suggestion for everyone always that to start practicing the test paper, right? Why? Because you can test yourself, you can judge yourself how good you are in any particular topic and how fast you can recall the concepts, etc. Right? So my suggestion is just start solving the test papers. Okay. So just yes. And revise the things whatever you are studying, right? So these are the different books from the Shastra. I suppose you must have got the one is there over the screen. So first start with these books, go to the theoretical part, then start with the short example, then go for the practice exercises or the class exercises, and then later on move to the practice exercises, right? So if you are not having these books, you can just send an email at support@edushastra.com or care@edushastra.com, right? And also at Edushastra, we have the online portal for writing the examination as per the examination pattern which you are opting for, right? Whatever the exam you are opting for. So you can start attempting the test papers, section test, topic test, complete test paper. So to get activated these tests, you can again send the email at support@edushastra.com or care@edushastra.com. So the team will activate the test. And the second benefit for attempting test is here in EduShastra, we are having sessions based on a different percentage score, right? So some sessions are like 50 to 60, 60 to 70, and so on. So these are the type of different sessions. So when you are attempting the test and you are having say, some scores, right? So these scores are analyzed by the participants as well as the team of Edushastra, right? And then they will upgrade you to the higher level of percentage classroom sessions, right? Online classroom session. So you will get a confidence, okay, I am in a 70 to 80 or maybe 80 to 90 percentage session, right? So I can score this one. So this will benefit for you and this will boost your confidence, right? But yes, this can only be done once you write the test papers, right? So start writing the test papers. Okay. Okay. So now moving further for the today's session. So I suppose that you must be there in the previous session where we have discussed the ratio and proportion. So I told you ratio and proportion, percentage, and average, right? These are the three topics which are very, very important and having a different uses across all the topics, maybe time and distance, geometry, algebra, and yes, major uses are in data interpretation, right? So just be a little good in calculation, uh, quick calculation for the percentage, for ratios, for average, etc. Right? And now today we are moving with the application, one of the application of ratio, which is a mixture and alligation, right? So I suggest everyone to just solve the questions, right? You can take up a say pen and paper, solve the question. You can type in the chat box. You can unmute yourself to speak out your ideas, your answers, your solutions, right? So, can you tell me what is the mixture and alligation and what is the concept we are studying in this part that is mixture and alligation? Yes. Can anyone tell me what is there in mixture and alligation? Yes, anyone can tell me. You can unmute yourself and you can speak out. What is mixture? What is allegation? No, no one. Okay, Shah is saying it involves mixing of two to three more ingredients with different cost or concentration. Okay, so Shah, this is the example, like what we are doing. But what is mixture and allegation? Is there any definition? Is there like some formula for this? So, okay, so hello Anadi, can you tell me what is mixture and allegation? Okay, Krishna is saying mixture combination of more than one item. Allegation, I don't, sir. Okay, okay. So, so allegation, Krishna is putting a blame to someone, right? Hey, you are not good, you are bad, right? So this is the allegation. Very simple. Oh no. Okay. So just moving with this part, that is a average mixtures and allegation, and for this. I suppose that average is very, very simple for anyone, and say most of you are working professionals in different capacities, right? You must be calculating the average salaries, average number of hours, average weight, average speed, right? You are going to college or your office, so you must be calculating okay, what is my say average consumption of fuel, right? So these are the various uses. Average is very, very common. And in this, what we do, we just add up all the readings, the entries, and then divide by the counting of the readings or the entries, right? This is very simple. Okay, so if I say in a class, there are some boys, right? And there are some girls. Say boys are 40, right? And girls are 30, right? And the average marks for the boys are 75, and for the girls, say this is 80. Then I want to calculate the average marks for the class. How can I calculate? What is the average marks of the class? Yes. Answer is not important. Just tell me like how can I go further and how can I calculate the average marks of the class? Yes. Oh, this is very simple. No, nobody wants to discuss today. What happened? So Krishna, I said, okay, Anadi. So number of boys, yes, 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 right. So this is if I want to calculate for the average marks for the class, right? So this is what number of boys 40 and multiplied with the marks for the boys. So these are the total marks for the boys, right? Yes, Nandini. Yes, Nadi. And then this is 30 multiplied with 80, the marks for the girls. And then we are adding them. So this is the total for the class and divided by this by number of boys and plus number of girls, right? This is the very simple. So this is nothing but what we are saying. Can I say this is what? Weighted average, right? Because for the 40 girls, right, or say for the say 75 marks of boys, what is the weight? 40 boys, right? So this is representing for the 40 boys. Similarly, 80 marks for the girl, but this is the representation of for what? 30 girls. So this is what weighted average, right? So I can write this as number of boys multiplied with average of the boys plus number of girls multiplied with the average of the girls divided by the number of boys plus number of girls. Very simple expression, right? So I just reframe and just restructure this, right? So can I say, taking up this simple as a average, so cross multiply average and 1 plus average and 2 is equal to what? And 1 S1 plus and 2 S2. Huh? Shift the terms. Average N1 minus N1 S1 is equal to N2 S2 minus average N2. Right? Just a shifting of the terms. Right. Take a comma N1. So this is average minus S1 is equal to N2 S2 minus average. Right? Now this is N1 upon N2 is equal to what? S2 minus average divided by what? Average minus S. Right. So there is nothing new. I have just rearranged, just restructured the formula, which was this. Right. So in the earlier form, we are saying this is for weighted average. Right. So you have some number of boys, that is a some quantity, and there is a some average, and you are calculating the group average. So we are calling this as a weighted average. That is, you are finding the average of the entire group. Right. But suppose if I give you the average of the entire group and I ask you, okay, tell me okay, how many boys are there in the class and how many girls are there in the class. So this is what? This is nothing but alligation. Right? So there is nothing new. This is just the rearrangement, restructuring of the weighted average formula. Whatever the variable we have, the same variable are there in this, but they are just rearranged. So in this, what we are calculating N1, number of boys, N2, number of girls. So this is giving me the ratio, right? Ratio of boys and girls. The earlier one was giving me the average of the total group, the boys in the group. But now we are getting the ratios, number of the quantities, the ingredient, right? So in a alligation, whatever we are mixing, we are calculating the ratio or the quantity, right? So this is what my allegation, right? Now coming to the this part before proceeding further, tell me one thing. There are two terms. One is mixture, right? And the other one is solution, right? So can you give me the some difference between these two terms, mixture and solution? What is the difference between mixture and solution? You can speak out. You can unmute yourself and you can speak out so that others can also listen and they can add some points. Okay, Krishna is saying solution will dissolve. Okay. Mhm. Mixture is still you can separate. Okay. Mhm. So hello Krishna, can you give me us some example? Can you speak out?
Sir, let's say in the mixture, in the sense, two fruits mixing in and selling it as a single basket is a mixture,
Mhm,
and a
mhm,
solution it's like milk and water, and or water and like sodas or something like this.
mhm, mhm,
Which means solution
mhm,
you can't split back again, but in the mixture you
mhm.
can split back. I'm just giving out my opinion. Maybe I'm wrong.
Okay, okay. And hello Tanushri, can you define what is mixture and what is solution?
Yes, sir.
Yes.
Sir, a mixture is actually the mixing of homogeneous components,
Mhm,
solution is a mixture of two homogeneous components, and in a mixture,
mhm.
the components are heterogeneous. So, in a mixture, components can't be separated, but in solution, it can be.
Okay, okay. So basically, as we are not studying the chemistry, so we are not going into the deep of these terms like what is heterogeneous, what is homogeneous, etc. Right. We are just going in a simple expression, simple definition. When you are mixing, right, two, three more items, ingredients, and after the mixing, if you are not able to separate them, then this is called as what? Solution. Right? For example, water and milk. After mixing water and milk, you cannot separate. Right? Then water and cool drink, you cannot separate. Right? But if after mixing you are able to separate them, then this is called as what? Mixture. So milk and petrol, water and petrol, rice and wheat, apples and mangoes. So when you're mixing them, you can separate them. So these are the mixture. We say mixture of boys and girls in a class, in a college, right? We are not saying solution of boys and girls, right? We are saying mixture of gases in the atmosphere, right? Because we can separate the gases. We are not saying solution of gases in the atmosphere. So in solution, you cannot separate. In mixture, we can separate, right? So alligation is primarily applicable for mixture. That is where you are able to separate the ingredients, right? But in the questions, you will find these two terms interchangeably, right? The examiners are not making any difference, but primarily the purpose of the allegation is to separate the ingredient, right? Whatever are mixed. Okay. So moving further, tell me, suppose there is a sugar, right? Sugar one, and this is price at rupees 10 per kg. Okay. There is a sugar two, and this is suppose rupees 15 per kg. Done. Separate. I want to mix them, and I want the mixture should be rupees 12 per kg. So can you tell me how much I should take the first one and how much I should take the second one? What can be the possible ratio for taking up a mixture prices 12 rupees per kg? Yes. Okay, Muskan. Okay. 1.5 and 1. So Krishna, how is this 1.5 and 1?
Sir, it's so the second sugar is at 15. So
Mm-hmm.
S2 I took it as 15 and the average value both it should come towards 12.
Mm-hmm. Mm-hmm.
So 15 minus 12 would be 3 on top, and then the in the same formula average minus S1 would be 12 minus 10, so it would be 2, so 3 by 2, so
Mm-hmm.
1.5 is to 1 or 3 is to 2
Okay.
in ratio.
Okay. So basically, as we have discussed in the ratio session, ratios are the simplest number, right? So if there is just some common part, decimal, normally we are removing them. Ratios we do not represent in a decimal, right? We represent them in a proper natural number, the complete number, right? Okay, so I want the quantity for the sugar one, sugar two. So can I say this is what quantity of first to the quantity of second? Then using this. So earlier, what the this is N1, 2, and 2, number of boys and number of girls. Now I am saying the quantity of first sugar, quantity of second sugar. Then S2, that is the average of the second. Right? So this is what 15. Then the group average is what 12 divided by the group average 12 minus the average of the first part. And this is coming out to be 3 by 2. Yeah? But when we're using the formula, so sometimes we make error and under again the exam pressure, what to take first, what not to take first, right? And shifting the variables. So sometimes we are getting answer in negative and we feel that, hey, yes, so this is a possible, right? But see, ratios cannot be negative, right? So what we are doing, rather than using a formula, what we do, we are using a little diagrammatic representation. And this is sugar 1 and this is sugar 2, right? So whatever the variable you have, just write them little apart, right? Making us some difference. So this is how much 10, this is how much 15. Okay, done, simple. Now average is 12, so write the average in the middle, little low, right? Now, what to do? From the bigger number, subtract this average. Right? And from this average, subtract the smaller number. Okay. So 15 minus 12 is 3, and 12 minus 10 is 2. Right. So sugar 1 will be taken as a 3 part, and sugar 2 will be taken as a 2 part. So ratio is coming out to be 3 is to 2. Right? So here we are not concentrating what is the first, what is the second, what should I write, what should I not write, right? So this is a little simple approach, right? Getting this? Any question, any query till now? Okay. Now, so there are two different type of sugar, sugar 1, sugar 2, and sugar 3. Now, suppose I say there is a one more sugar, right? Sugar 3. And this is priced at rupees 20 per kg. Okay, so there are now three types of sugar 1, 10, sugar 2, 15, sugar 3, 20. Done. I want to mix all three. Yeah. And I want the price as rupees 12 per kg, the average price after mixing the three different types of sugar. Done. So tell me, what is the ratio for the sugar 1 to the sugar 2 to the sugar 3? In what ratio I should mix all three different type of sugars? Yes. In what ratio I should mix all three different type of sugars? Sugar 1 rupees 10 per kg, sugar 2 rupees 15 per kg, and sugar 3 rupees 20 per kg. And I want the mixture to be at rupees 12 per kg. Should I say 3 is to 0? What does this mean, Shia? 3 is to 0? Can you?
Sir, I basically calculated like sugar
Mm-hmm,
mixture 1 is to 3 first, that is
mm-hmm,
10 and 20. So it
mm-hmm,
gave me ratio of 4 is to 1. And
mm-hmm,
then I took the result of that mixture with the ratio of sugar 2.
mm-hmm.
So 15 minus 12 by 12 minus 12 gave me 0.
So you mean to say that you do not require the sugar, but still you can sell the sugar at rupees 12 per kg,
No, there is some mistake, I think.
right? So 0 means that there is nothing and still I'm selling and getting the money, right?
Yes, sir, I am checking.
Okay. Okay, so this is fair and waiting for others. Yes, to give some answer. See, when you solve, you realize what the mistakes you're doing, and it is very good to do the mistakes here, right, rather than doing the mistakes in the examination. Done. So this is the reason every time I suggest everyone to take a notebook and pen, paper, etc., and solve. Right. Do not be just a simple spectator. Right. Maths cannot be learned as a spectator. Right. Until and unless you do not solve, you cannot learn. Okay. So who will be the next and giving us some answer? Hello, Mahadi. How are you?
Yes,
So
great.
I thought there is a big rain in Indonesia.
There is what? Sorry.
You're from Indonesia, huh?
Yes.
Yeah. So I suppose there is a huge rainfall yesterday.
Mm, yeah, but I'm not really impacted, I think.
Okay. 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 So what's the answer?
7 to 1. Is it like that?
7 to 1.
Yes.
Okay. And how is this?
Uh, we can calculate that the sugar 3 and sugar 1 average at 15, and then we can use
Mm-hmm.
the previous calculation if you want to include
Okay.
each sugar.
Okay. Okay. So you're saying that first I should take the average of first and third,
3.
and then
Yeah.
taking the this. So why are you taking first and third? Why not maybe the first and second or second and third?
It's because the third sugar is very heavy. So
Okay.
I'm just making it easier, I think.
Okay. Okay. And okay, now Shreya is again giving us some answer. 4 is to 1. We know we don't need to consider sugar 2 here as they are same 12. Huh? Sugar 2 is 15 here, not the 12. Average price I need a 12, right? But sugar 2 is 15. Okay, and yes, yes.
So I wanted to say like since sugar 1 and 3 are already making a ratio of 4 is to 1, so we don't require sugar 2.
No, no, no. See, normally what we do, we make some assumption with the kind of variable, right? So we are taking a sugar here. So we are assuming that okay, we do not need the sugar too or whatever, right? But assume that you are uh, say civil engineer and you are constructing a building and you are preparing a mix of concrete, right? So you need a sand, you need a concrete, you need a cement, right? You need a different thing. And to make this entire mix, you're taking a different ratios of all these ingredients and making them a one mix which can hold the entire building, right? So you cannot say, okay, this is like this, so I cannot need a cement, right?
Yes.
Getting my point?
Yes.
So, see, this is
Okay.
something like the variable which we are having. We are making a some assumption. Okay, I can take this, I should not take this. But yes, if the question is saying, we have to consider. Okay. So, Preeti, hello, Preeti, can you unmute yourself?
Yes, sir.
What's your answer?
So 12 ratio 8 to 3.
And how is this?
Firstly, I'm applying allegation formula in S1 and S2,
Mm-hmm,
and we get 3 ratio 2,
mm-hmm,
and also apply allegation formula in S2 and S3, and then
mm-hmm.
get 8 ratio 3, and S1,
8
S2,
ratio 3 or 8 ratio minus 3?
no sir, 8 ratio 3.
Check करो एक बार. Or maybe minus 8 is to 3.
Yes sir,
One
minus
term
8
should
ratio 3.
minus आ रहा है ना.
Yes sir, yes sir.
But tell me कि can ratio be negative? क्या
Hmm.
रेशियो नेगेटिव हो सकते हैं?
So I think नहीं.
सिंपल एग्जांपल, सपोज मैं आपको कहता हूँ कि मैं आपको जो है कैडबरी एंड 5 स्टार चॉकलेट देता हूँ, है ना?
Hmm.
एंड आई विल गिव यू कैडबरी एंड 5 स्टार चॉकलेट इन अ -2 to -5 रेशियो. तो पॉसिबल है क्या?
No sir, is it not possible?
पॉसिबल नहीं है ना? तो
Hmm.
we have discussed this in a previous session when we discussed ratio, that ratios cannot be negative. Ratios are the simplest number, right? जहाँ पे co-prime होना चाहिए. Okay,
Yeah, okay sir.
चलो अभी करते हैं. Okay, Krishna is saying 7:2:1. Okay, how is this, Krishna?
Sir, I use the weighted average method, like
Mm-hmm,
the same formula N1, S1, N2, S2 plus N3,
mm-hmm,
S3 by
mm-hmm,
N1, N2, N3. So
mm-hmm,
N we don't have, but the S value we have. And
mm-hmm,
if we substitute it, then we will reach in an equation where it says 2x1 will be equal to 3x2 plus
mm-hmm,
8x3.
mm-hmm.
Then substituting the whole numbers, and then you get like you play with the numbers and you get the value.
Okay. So tell me, Krishna, one thing as you're saying is you're using this same formula, right?
The
So
one at the top, sir.
Acha, okay. This
The
one.
first one, yeah, yeah.
Okay, this one. Right. Okay, so this formula, as we are saying, okay, we are deriving the allegation from this wicked average only, right? So if
Yeah.
this is the formula, so this should be the formula allegation, right? We should
But the
also get the
third
same.
the third quantity is making little bit complex, so I just left it off.
Yes. Yeah. Okay. So
So
you
I went
feel
with
that,
yeah,
so yeah, so you're taking your comfortability and then whatever is like suits you, you're taking up, and whatever is difficult, you're leaving behind,
yeah.
right?
Yes, sir.
And very simple, right? You can check here when you're taking a say three quantities, right? So can you take a ratio something like n1 upon n2 upon n3? Is this the way? Can I take a ratio? No,
No,
we can only take a ratio for two values, right? Two values. Right? Okay. So for this, what we do, if you are having a multiple quantities, right? So we will apply this formula multiple times, right? Now see how. I need the average value 12 rupees per kg. Okay, so what is average? As the name suggests, as the definition suggests, okay, whatever you have, average is something in between, right? So average always lies equal to the smallest value or greater and lesser than the highest value or smaller, right? So that is average is in the range of smaller to highest value. Done. So if you are taking a these two, as Preeti is saying, I can take a 15 and 20, right? So if you're taking a 15 and 20, tell me anyhow with any formula, can you get an average of 12 rupees per kg? Is there any possibility? If the smallest value is 15 and highest value is 20, can you get the 12 as average?
No, sir.
No, right? There is a no way. So
So,
this combination we cannot consider, right? So whenever we are taking up some combination to identify the allegation or the average or mixtures, right? We always consider a pair where the average value should come in between, right? So what I can do, I can take one pair is this first and second, 12 can be the average, and then I can take this pair that is first and third, 12 can be the average. Okay, so we have done this part, that is a S1, S2, and taking averages 3 to 2, right? This is the first part. And then if I take the first and third, so I can say sugar 1, this is sugar 3, this is 10, this is 20. Write this in between, subtract from the bigger value. So this is 8, right? And subtract this from the average. So this is 2, and ratio is coming out to be 4 is to 1. Right? So now you have a two different ratio. One, this one for sugar 1 and sugar 2, and the second one for sugar 1 and sugar 3. But I want to mix all the three, right? So when you're mixing, so all these mixtures are there. So now what we do, we have sugar 1, we have sugar 2, we have sugar 3. Then how much sugar 1? 3. How much is sugar 2? 2 in the first, right? And how much is sugar 3? 0 in the first. When I go for the second, sugar 1 is what? 4, sugar 2 is 0, and sugar 3 is 1, right? Done. Now, when we are having a ratios in this format, when there is a one common ratio, so what is the learning we have in the past? We multiply or we take the LCM, right? But here in the allegation, you will not multiply, you will not take the LCM, you will add these ratios. So this is 7 is to 2 is to 1, right? These are the ratios. Why? Why we are adding? See, when you're mixing up, so there must be some quantity, some weight. So the first you are taking how much? 3 is to 2. Total 5 part, right? Second, you are also taking 4 is to 1. Total 5 part. So 5 part plus 5 part, this is adding up to how much? 10 part. So 7 plus 2 plus 1 is total 10 part, right? So this is the reason we are adding up here rather than we are going to multiply, right? So if you are having a multiple variables, you can identify the allegation in this manner.